Welcome everyone. I'm going to be playing with a big box of sensors. Right now I'm just setting up my live stream setup, so I should be starting in about 5 minutes time. And I'm also trying out a new setup. So I can now read this live chat directly off my Raspberry Pi. Computer stuff DIY, and I'm also going to try streaming on both of my accounts. So if I open a second window here and run my local host, 8082, right, so that one's not, well, of course it's not, I haven't copied the file over yet. Right, let's copy that one. I noticed that, very cool. Is that custom built yourself? Yes, I've been playing around with Node.js. And remaster. So I'm just updating the index file on the other one. Overwrite. And now I should be able to run the second server. Yeah, I've got technology, Foreman Technology Limited, and I've got CK Enthusiast. Right. So I'm now connecting to the second one. Right, is that the right name? It might just be Foreman Technology. Failed to retrieve, user might be offline. Did I actually start the live stream? Ah, my phone's gone off. That would explain that. Okay, we'll just do a single stream now. Yeah, phone's run out of power. I thought it was charging up properly, but apparently it's not. That's fine, I'll just carry on with this one then. Thank you for the like, I appreciate it. Right, so basically I've got a big box here of Raspberry Pis and sensors, and I'm going to try and get my sensors working with this. The idea in the long term is to, just stretch that out a bit, is to build a Star Trek style tricorder. So I've got a little screen here, which I'll pull out of the box now. Just, yep, that's in view. Okay, so I need to bring that further up to be viewable. So I've got a little display screen there. This uses SPI. We've got some power adapters and LEDs there. This box here is the box of sensors. So I'm going to take all of these out, and I'm going to start by soldering the pins to all of these. So they're ready to swap in and out and basically experiment with. So we're going to start off with a bit of soldering. So these are all sensor boards. We have, I'll bring that down a bit. There you go. Oh no, didn't like that angle. The springs were a bit too low. Right, so if I load that there and zoom in a little bit, move it there you go. So we've got all the sensor boards here, including a camera sensor. I don't like the fact that my activity keeps overlaying it, so I'm going to bring that down a bit closer. Bring that over here. There we go. So we've got things more centered now. Thank you for the likes. I appreciate it. So we've got a BMA 688 sensor. This one's already been soldered, as you can see. This will do temperature sensing, gas analysis, and it will do altitude, I think. Yes, pressure sensitive. So it will take pressure, humidity, temperature, and everything else. So that's going to be one of the main features of my tricorder device, is environmental scans. The other one I've got here is a time of flight sensor. So this literally beams out a signal, it bounces back, and you calculate the distance. We have here what was this one again? I'm trying to remember. This is a 3-axis accelerometer. And this is a color sensor. So this will detect smoke, RGB color, and luminance levels. What else we have? We have a 6 degrees of freedom sensor. So this is accelerometers as well, but it also has a magnetic compass built in. So it will point magnetic north and calculate its rotation based on that. And the final one I have here is an optical sensor. So this will do oxygen meters, it will measure heart rate, and it will measure smoke in the atmosphere. So those are the sensor boards. And my idea, or my plan, is to try and integrate all of these into a central computer, have a display that I can cycle between, and actually get all these environmental readings based on the display. It won't be a project that's finished today, it's going to be a long-term one. But say first steps first, I've got to start soldering these things with some extra pins so I can get them all connected. And all these boards cost about between £5 and £10 each. So they're not massively expensive if you buy them slowly over time. So if anyone has any questions about what I'm doing or just wants to talk about something else, please feel free. I'm more than happy to have a discussion while I do this. So I'm just going to heat up my soldering iron. Yeah, it's telling me Porkies, it's not actually. It's telling me it's heated up, but it isn't. So I'm going to turn that off and on again. Maybe it just went to sleep. Give that a moment to catch up. It's a Raspberry Pi camera. I've got a Raspberry Pi camera here, yes. This is one of the additional optical sensors I plan to add to it. Classic IT fix. That's one of the biggest smartwatches in Christendom. Yep. It could all be added into one smartwatch. At the moment, my long-term goal is to make a tricorder from Star Trek using real sensors. So we've got atmospheric sensors, we've got heart rate medical sensors, we've got environmental directional sensors, all that kind of stuff. So my first goal is to add the pins to all these boards and then start loading them up on my Pi, get some sensor data back, and basically make sure all these sensors work with my Raspberry Pi 400. It should be a fairly easy but somewhat time-consuming event. All right, that smells like it's actually heated up now. Is it possible to make a drone? Yeah, of course it's possible to make a drone out of a Pi Pico. It's actually quite a powerful little processor. You've got a dual-core ARM core processor on a Pi Pico. The biggest thing is, I'm glad you enjoy my content, mate. I really am. If it wasn't for people here, I wouldn't be making anything. So one of my tricks for soldering is just to take a breadboard, stick the pins in like that, stick the board on top, and it's nice and easy. That's if you try not to look around the camera at the same time. There we go. Let's get these pins on there. And I'll just solder these all down now. Love the smell of lead in the morning. Normally when I do it, I'm like hunched over like this, but because I've got the camera, I'm kind of sitting back, and I have to admit, my distance vision isn't the best. I'm I'm good at up close things, but I'm not so good at long to medium. Right, let's get these pushed to one side. You can zoom in here as well. And you may get my head in the moment. So that's one done. As easy as that. That one could do with a touch more solder, but there's a good connection there. And the board is a little bit warm, so I've probably heated that up a bit too much. I'll let that cool down before I touch it up again. Been meaning to do some monitoring with hydroponics with a Pi. Where did you buy these sensors? These are all from Pimoroni. I really go to them first for things because they have all the library set up, and I don't actually have to do that much to get these things working. And then I can take what I've learned and move it onto my own projects. So this is right. So this is an 8x8 time of flight sensor array. So it will literally take distances using this sensor in a grid of 8x8. So I'm going to solder my connections to this one. Thank you for the likes. I appreciate it, guys. There we go, there's the next one made. Oh no, I've missed a pin on that one. Let's try that one again. I need to wipe the tip of my iron. There we go. Much better. So there we go. So there's the next one soldered. Connection looks fine. So that's the next one done. This one's already been soldered. This is a BMA 688. So this is the environmental sensor. It will detect air quality, temperature, pressure, and humidity. This is the 3-axis accelerometer. And I'll get this soldered. That one needs reflowing. There we go. Yeah, that looks fine to me now. Thank you. I'm glad you enjoy my videos. Soldering, no. You'll mess it up the first few times, but honestly, it's just holding one hot thing onto some metal that that flows. I don't solder all the time. I kind of do it every few months or so, and first one I always do is a little bit crap. Then the next one, it's just, yeah, get it on there quickly. Melt your solder and wander off. But it's like anything. You practice a little bit, you'll be good at it. It's not expensive to get into. Get yourself a £15 iron, a reel of solder, and just practice soldering some cables. In fact, I had a kid. I didn't have a kid with my ex. My ex had a kid, and while I was there, I taught him to solder, basically by buying him a big reel of wire, showing him how to tin the wire, and then getting him a big pack of, what do you call it? Matrix board. Where's mine? Oh, easier to show. I saw it just 5 minutes ago. Where's it gone? There we go. So you just buy a big pack of these. You get yourself a soldering iron. This will cost you about a tenner, maybe. Get yourself a soldering iron for like 15 quid. Solder usually comes with it. Get yourself some wire, which will be like £1 or so, and just practice soldering wire to this. And in no time, you will be pretty proficient at it. Can you spot solder, which is basically arc soldering? I don't do any kind of welding, no. I can solder with a hot gun and some flux, but that's fairly easy. How many of these did I do before I got off track? I think there's one more. Yep. Last time, I don't know what was wrong with your soldering iron then, because mine definitely doesn't smell like fish. There we go. So there's the next one done. Don't be scared of it. Just get a better quality solder. Thanks for the follow. I appreciate it. There's really no reason in the world to be scared of a soldering iron. So you got my box of goodies here. Try zooming out. Will you let me zoom out? There we go. You got my Raspberry Pi sensors and board box. So now I've done all these, I'll basically put all these back in the box and bring them out one at a time. I'm trying to be a little bit more organised in my life now. Now, is there one I've missed? Because I've got an extra one of these things. I don't see one on my desk. We have time of flight, 688, color sensor, axis, and we have time of flight. I think I am missing one. I'm missing the heartbeat sensor. Accelerometer, air quality, that's the time of flight, yeah. So I definitely don't have, that's a colour sensor. So I'm definitely missing one. Where has that gone? He's now checking the floor to see if he's dropped it. Don't look like it. It's underneath my camera. Okay. Crisis averted. I'm glad I spotted that I had an extra one. Gonna zoom in now. Yep, under the camera. I'll say the biggest thing when it comes to soldering you need to learn is how to have 3 hands at the same time. You often got to hold something in place and hold the solder and hold the iron. So working out a good strategy for holding whatever you're soldering in place is a really good start. As you can see, all I do with something this simple is stick it in a breadboard. Gotta wipe that down. How do you plan the project? So I've got no idea what to achieve, no idea how to get there. Well, you pretty much set out the steps for yourself. You decide what you want to achieve. And then it's a matter of reading and taking some interesting paths until you get to your destination. But it's just like writing a book. You have your beginning, you have your middle and the end. And one thing I always plan whenever I write a book is what's the ending going to be? Because if you have an ending, you have a destination. And if you have a destination, you can start working out the path to get there. Yep, that looks pretty decent to me. No, you don't need flux for this. Flux is really for when you're dealing, as he says, when you've got lots of tiny little pins and you need the solder to flow onto the contact pads rather than going all over the board. What core solder? I'm not using anything fancy. This is just standard solder wire, 0.6 diameter. Flux 1.6, so this actually has flux in it already, which is why at this scale you really don't need to add additional flux. But for video content, flux is great. You get to flood a board with it, and then you get to do your expert soldering, and visually it looks fantastic. But in many cases, you really don't need to use it, to be honest. Certainly not at this scale. What course? I got the idea. Guess finding the components and the functions. Yeah, I mean, what's your idea? Once you have what you want to do, it's a matter of planning out the hardware you need. And I would say for a first-time project, go as easy as you possibly can on yourself. One thing that will instantly kill anyone's hopes and dreams is by taking on a massive project that they really don't know much about. Small projects, work your way up, and you will be a lot more confident going forward. So yeah, if you're going to start trying to make yourself an entire ham radio from scratch with a 4-bit processor and a memory bus, then you're going to kill yourself directly. But if you're just going to build yourself a simple sensor board that will take some readings from your environment, then there's plenty of pre-made solutions. It really is just a matter of dialing down your expectations until you've got the experience to achieve what you want to achieve. So I'm going to be running this off my Raspberry Pi, and I'm basically going to go through the procedure of installing all of these boards into my Raspberry Pi and see if I can get data off the boards. I would advise to use flux. You don't need flux. There's flux in the solder. You don't need it. You're just going to make a mess for no reason. Now, if you were doing something like, you see those tiny surface mounted chips, that's when you use flux. When you're dealing with things that tiny, that's when flux becomes important. When you're dealing with pins that big, you really don't need the stuff. Thank you for the follow. I appreciate it. Right, so let's just grab any random sensor. Doesn't matter which one to get started. The Pimoroni stuff is really easy to get started with. They basically give you everything you need in terms of software library, so you don't have to be a coder. You just get on with the instructions on their website. So I'm going to try and get that in there. So the first thing, right, my doodah's a bit wonky there. Let's tighten that up a bit. So I'll try and keep it. I'm going to take my keyboard off because I might type in passwords and things. So I'll try and focus on the screen and what I'm doing with the sensor. So obviously you've got the GPIO cable here. So all I'm going to do is take my wires, which I have some prepared already because I've done this with another board. So I'm just going to take these jumper cables and I'm going to start plugging them in. So now I've got the pins. I'll bring this down again. Now I've got the pins soldered there. I'm just going to connect these wires up in sequence. Now the reason I'm doing this rather than using a breadboard is because I had loads of problems trying to get the sensor to work with my breadboard. As soon as I connected it directly, all those problems went away. So I'm just going to skip the breadboard for now, and I'm going to plug it in this way. Actually, you know what? I'm not. What I'm going to do is make something. I'm going to get a bit of my clipboard and I'm going to make a proper setup for this because I have a bunch of these other kits. Where did I put it just now? This is what I'm famous for. I will put something down and then 2 seconds later, where the hell did I put that? There you go. I put it away automatically and that's why I can't find anything anymore. Why have you got a USB cable connected to the same USB-A port? I have no idea what you're talking. Oh, this. I've put a little SSD in there. So that's a USB Type-C SSD in the Raspberry Pi case. And it's connected to my USB 3.0 port. And that gives my Raspberry Pi 400 a big speed boost. But well spotted. Took me a moment to realise what you're talking about. The storage, I just got a cheap one. Because I format it all the time and there's a risk of me breaking it, I just got a cheapo. So I'm going to take these and I'm going to make a little sensor board thing. And I'm going to use one of these to do it. No, I'm connected to, like I say, it's a quick and dirty way of getting, now, I want to eventually do multiple linkages. So what I might do, no, I'll do a small one for now. As you can see, I don't do a lot of planning ahead. I am making this up as I go along. Those 20 by eBay, most likely malware. Yeah, dude, you can tell if there's files on there. Just don't double click on anything. You have to actually execute the file yourself. Now, there are some USB drives that pretend to be something other than they are. Those you have to be a bit dodgy of. But yeah, you can typically see when something's going on. Yeah, so that way I can just connect this in here. And I can swap them out a bit easier, because trying to get those individual cables on is turning out to be a bit annoying. So I'm just going to solder this down. Yes, there are hats for M.2 slots. Pi 400, probably not the best use case for it, because it'll be sticking out there. You'd have to solder something in there. And the main reason I went for a USB one is because I want my GPIO free. As you can see, I play with electronics, so keeping that free is a good idea. As you can see, I am successfully soldering without the need of any flux whatsoever. There we go, that'll do. Philips monitors, yeah, I mean, they're not amazing color quality, but I go for cheap. So yeah, they're cheap. That's pretty much the appeal for me. So now I can just plug this in here like so, and I have myself a little mount. So all I want to do is break out some cables now, so I can just plug them into my Raspberry Pi. Don't start the great flux debate. There is no debate as far as I'm concerned. If I can make a soldering joint without using it, I've proven my point. Yeah, micro soldering is when you need it. I'm not doing micro soldering. I'm very much doing macro soldering. This is just standard electronic parts. So what I want is some pins with a female connection. So I'm just going over my various connectors. I'm pretty sure I saw one earlier. Actually, I might use, no, that's 4. There's any more. Any other questions? Imagine going on the Piers Morgan show to debate the flux issue. The debate is constantly in flux. That appeals to my sense of humour. I got loads of the female to female. Well, aha! I knew I saw some somewhere. So I'm going to take one of these ribbon cables with a nice pin on it already, and they got female on the other end. So I'm just going to strip off 5 of these cables. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Peel that off. Then I'll just stick these through there. And then these can go onto whatever I'm connecting to. So I want to make sure these are in order, otherwise I'm going to confuse myself later on. Let's get these lined up. And yeah, a little hack for this. Where's my gaffer tape? I just want a little bit of gaffer tape to hold it in place. And I put the reel somewhere sensible, which means I can't find it. That's fine. I'll just do it the hard way, it doesn't matter. All right, let's get these lined up properly. And get these in the right holes. Come on. There we go. Got them through. So I'll just solder these down now. Let's put something weighted on there. This is called How to Solder at an Odd Angle. Now I'm putting an extra amount of solder on these because I'm going to bridge the joints in a moment. Actually, I can just bend the pins over. Nah, just join them with solder. It's quicker. There's one. And that's the other one. I should get my helping hands out really, that'll make things a bit easier. There we go. Put it the other way around actually. I've got something weighing down the one end of my cable, so just trying to sort that out. Need a little bit of extension. There we go. Now a bit freer. I think he's just going through the holes in the board. Let's do the bridge further up. There we go. Yeah, the holes on this board are so big, it's just going through the bottom. That's quite funny. Normally it would pool at the base and then climb up, but it's just falling through. I think I've done 3 of them, that's not too bad. Yeah, just those middle 2. They're the problem. Right, I'll try bridging it again. Okay, plan B. I'll fold over that pin and I'll solder it that way. It's just literally pouring through the hole at this point. Just bend the pins over. Connect them that way. It's a quick and dirty job, I really don't care. I'm not really about aesthetics. There's a lot of good product design these days. Depends what circles you run in, really. But a lot of engineering these days is taking pre-made solutions and making them work together. There we go, that was easier. I should have just done that from the beginning. Right. I don't see any crossover connections. We should be good. Everything looks the same. There's no innovation. Trouble is, it's not just the fault of the engineers. It's the fault of the public and what they're willing to buy. At this point, everyone just wants a black slab of glass with a camera on front that they can say, ooh, isn't it fancy? They don't really care about the specs, which makes sense because especially phones, they've gotten to the point in technology now where they are just functional. It doesn't really matter what level of phone you buy these days. This is just a little extender board for my sensors. Alright, so that's working. I just want to check these connections are good. Actually, I should do it. Can I actually do it that way? Let's see if I can go in far enough. Probably can't. Nope. So that's going to be the grey connection. So I'll pin that one down first. So I'm literally just working my way up each one just to make sure I haven't got any cross connections going on. So I got my pin on one as that's supposed to work. That's good. That's good. That's good. And that's good. This is another job for the helping hands. So I'll just bring those out again. So the white one is the next one I want to test. That's fine. Brown one, black one next, sorry. The reason I do this is because it does save time if there's a fault and you don't detect it originally. First PC I built was on Windows 98. I may have done the same thing. I can't remember. It's either Windows 95 or Windows 98. I think it was 95 because I got the OEM 2 edition. Yeah, that's good. Last wires check. Windows XP, yeah. Windows 2000, I loved Windows 2000. Mostly because it was Windows XP, but without all the annoying blue and green and silly colour scheme they came up with. That's good. Right, that's good. I can have some level of confidence now when I plug this into my Raspberry Pi, because I had so much trouble with one of these sensors before, and it turned out one of my connections was wrong, so I spent a lot of time wasted doing that. Right, anyway, so the entire point of this, Windows 11 is fine. It's not as bad as people make it out to be. It's just that a lot of computers won't run it naturally, but it's easy to get around. There you go. So we now got my sensor mount there, and it's just a matter of working out which of these connections go to which pins on my Raspberry Pi. So this is, which board did I pick? This is the HR oxygen meter and smoke sensor. Okay. So the first thing I'll do is bring up the instructions from the Pimoroni website. Again, I didn't have a problem with Vista. It wasn't as bad as people made it out to be. The biggest problem with Vista was Apple's shitty marketing, where they basically allowed everyone to say, yeah, you can just install it on your own machine, and no one really understood what specifications you needed for it. Did your workaround for Windows 11 get put back on TikTok? I've no idea what you're trying to say there. I don't like all of the pre-installed affiliate stuff for Windows. Now, this is an aspect of Windows I don't like, and this is present in Windows 10 as well, is the fact that they're trying to push Bing through the operating system. So they're directing searches through Bing first. And of course, they're putting in a bunch of marketing stuff in there as well. That aspect does annoy me. I do not want to be advertised to on my own operating system. But on the other hand, I haven't actually paid for a copy of Windows since Windows 11. I don't mean Windows 11, I mean since Windows 7. I basically had a bunch of Windows 7 licenses, and every time a new one came out, I jumped on the easy upgrade wagon, and I've just kept upgrading every copy of Windows I've owned to the point where I've just got loads of Windows 11 copies and I haven't had to pay for it. And if that's happening across the board, then the side effect is that Microsoft needs to find other ways of monetizing their operating system. So it's a side effect of the fact that people want something for free and they're not willing to pay for it, and they're not willing to jump onto Linux. And remember, Linux makes money as well by selling to enterprise. I don't know how they still put Candy Crush on there. It seems very silly to me. But having said that, that's a horrible soldering job. That'll do. It'll do. But basically, every consumer wants something for free. And they don't understand, in order to get your Google services, in order to get your cheaper phones, in order to get your other hardware, you are selling them your data. And if you don't want to engage in that ecosystem, you have to go Linux. It really is your only option at this point. Max 30101. Pimoroni Max 30101. Right, so I'm jumping onto the website. So this is the Pimoroni website. This is where you can download all your drivers and stuff from. Got to turn my camera this way. There we go. So it's easy to use their stuff. The board's gone up. I actually got this for about a tenner because I think I got it in a Black Friday deal, but it's about $16.50 now. So it's not a cheap little thing, but they do give you well-documented instructions on how to get it. Ubuntu, I don't know much about Ubuntu data mining, but anytime you get an operating system that is top of the pile, like Ubuntu, the chances are they will start monetizing it in some way because they're companies and they need to make money. Software, Python library, straightforward to use your Max 30 sensor. We've included some examples of how to display it, so I suspect I'll need to jump onto their doodah. Oh, they've actually got a video, have they? Let's have a look at their video. Nope, that's something else entirely different. Okay, yeah. Sell me something somewhere, some other time, I don't care. Right, schematic. No, don't need that one. So it's IC2, that's fine, or I squared circuit, whatever you want to call it. It's basically SDA, SLC, INT, and ground. So they've actually got the pins written on the board, so I'll just connect it to that. I am terrible for remembering what the pins are on a Raspberry Pi, so I'm going to cheat, and I'm going to type pin out into terminal. So we have interesting. They haven't actually listed that. Okay, I'll just grab one off their website. Raspberry Pi GPIO pinout. They didn't put SCD and all that kind of stuff in there. I think I vaguely remember where it is, but I want to make sure I get the right connections. But that's the great thing about open source, is you might not trust a particular group or company, but you have the option of going somewhere else. I quite like System 76. I don't know if they collect data or not, though. I know they sell hardware, and I believe that's where they make their money. Okay, that's the pinout I needed. They normally have a GitHub I can just jump on. There we go. Community support and hardware, yeah. Oh, and investors, fair enough. But every company is going to hit a point where they're going to have to keep their investors happy. And to do that, they will often start selling people's data. Now, you might wonder why I'm typing this in rather than just copying and pasting. And the reason for that, I'll probably type that in wrong now, is because I have a better chance of remembering it if I type something in. Sudo /install. There we go. So I'm now installing all the software for it. I think they get it through the fact that they're a charity rather than a company. So they'll get it through donations, they'll get it through hardware sales. They'll also get it through patenting. Things like selling their RP2040 chips, all that kind of stuff. But this is just off the top of my head. I haven't done any real research into it. Warning, this code should not be used for medical diagnosis and as the basis of a real smoke or fire detector or in life-critical situations. It's for fun, novelty use only, so bear that in mind while using it. Ooh, they have to cover their arse legally on that one. Alright, ls. Right, so we've got some examples there. Yeah, I mean, you have to, because you know it will go so wrong at some point and someone will try and sue you over it. All right, where was my pin out? Oops, I forgot to turn off my my whatchamacallit. Now, which orientation is this? Right, that's pin 40, that's pin 1. Oh, I should probably bring this back down again so you can actually see what I'm doing. So I need to physically connect it now. We have... where's my GPIO listings? There they are. So that side is pin 1, that's a 3 volt. This takes 5 to 3 volt, so I use the 5 volt. I purposely put that on red, so this needs to go to power, which I'll put on last. Ground is a nice easy one, so this grey lead will go to ground. And so that's pin 6. And that's pin 0, so there we go. There's pin 6 there. Why is my thing beeping at me? Let's turn you off, thank you. That's ground. Let's run some physics simulators on this ventilator. Right. I need INT next. Where's INT? Does that actually need to be connected? Or is that just internal? Okay, have a look at the instructions, man. Mario on an EKG. Sounds healthy. Right. SCL 1. That's INT. I'm going to skip that one for now. I'm not sure if I need it or not. SCL is pin 5. So that's going to be this one. SDA would be this one. That goes right next to it. And I think this is clock. So that goes there. And then this one should go onto power, so I think that's the right connection setup. Okay, so in theory, I think I got the right connections in there. So the sensor should be working. Now all I've got to do is find my example code and hope it does what I think it does. Let's try detect particles. Python detect, delect, let's try again. Detect particles. .py. Okay. Failed to make traceback call. Device bit8 reg. No such file in the directory. What's that? Okay, let's try running Thonny. Okay. Let's try the other one then. Get temperature. Same errors. Okay. Now this is the 101 board, not the 105, isn't it? So maybe that's the issue. Maybe I need a different library. Oh, that's Arduino. That's for Spark Fun. So I'm guessing that the 105 supports the 101 as well. But they're not being very clear about it. See if there's any issues. Okay. Let's see if my wiring is bad. Let's start that again. Should be able to put this on in a row. Let's go into the examples. So it's still coming up. No such file or directory. File, detect particles, line 1. Line 204. Self address equals device bit reg file line 166 self dot. Okay. Let's see if it's the SM bus it's missing. No, same error. Thank you for the follow, I appreciate it. Now normally these guys are a bit slicker than this. Stable pi, just run max. Okay, let's see if there's a 101. Maybe they just screwed up their website. Sudo pip install max 31010. Could not find a version that satisfies the requirement. Okay. So it's got the wrong number written on the back of the board. 30101. Interesting. Okay, the next thing to test is this port I made actually working? I'm using Python 3. No, I'm not. I'm using Python 2. I suppose I could try Python 3, see if that makes a difference. Let's plug that back in there. Actually, should make a difference because I did run Python 3 in Thonny. No, same error. It says 2, does it? Okay. Yeah, no, it says 3 as well. So it should work with 3. Okay, I suppose one of the best things I can do, like I was going to do, is make sure that the connection is actually good, because I didn't actually test these pins here. So what I need is a bit of conductive material. I just want to eliminate the simple stuff first before I start going any further with the complicated stuff. So I'm just going to take this pin here and see if they're working as they should. And I know connections are working from there to there because I tested those earlier. So I just need to test these from here to here. Thank you for the follow. I appreciate it. Yeah, I should be getting a connection there. Ah, I'm on the wrong mode. I should be hearing beeps, shouldn't I? No, it's giving me a resistance. Okay, so now it's working. It wasn't working earlier. Now it's not working again. Let's try a different pin just in case. And I should have. Right, this one looks a bit more stable. I want it deep in there. So I know there's a good connection, and I want to test each one. Yeah, I did a sudo apt update before I began. But thanks for the suggestion. Right, that's working. That one's not working. That one's working. Get your helping hands down, you're too clumsy otherwise. Yeah, that pin's difficult. That one's not working. And that one's not working. Yeah, I got some connection problems. That's why I'm having issues. Okie dokie. Let's pull that off. I can't, can I? Because I sold it in there. I'll get another one and I'll try it with something else. Right. That was a failed experiment. It's usually the simplest answer is the most likely one. So I need 1, 2, 3, 4, 5. I can peel those ones off. Good. Last one. Come on. Stop being a clumsy bugger. There we go. So that's now on there. Right, there's my sensor board. So the 5 volt is going to be green. If I get these are lined up properly, we should have a nice simple direct connection. I don't want to go in there. There we go. So it's a new cable, so sometimes you kind of got to force it on there to get them working properly. There we go. Right, so power's that end. There we go, now it's on there. It would be nice if they had like a little LED or something on here just to confirm power's going to the unit, but they don't. Alright, so let's try running it now. Nope, same error, okay. But I've definitely eliminated connection problems now. though I need to double check that the pins are in the right place. That's 3.3. Yeah, that should be correct. Ground, clock. These are on properly. Ground, clock. SLC1, SDA2. 3.5, there we go. It does say literally between that, but I think 3.9 would still work. It will be something I test in a moment. Yeah, this is what's confusing me, is I've looked for the 30101, as it says on the board, but everything else is referencing the 30105. So I suppose I could move on to another sensor board and make sure that's working. I will stick this in the don't know why that's not working pile. And we'll try something else. Now I think these all use standard format. So we shall try, and I won't use the color sensor, that's going to be complicated. Let's try, I just want something simple just to prove things are working. Well, I'm looking for my 3 degrees of freedom, my accelerometer, that's time of flight. Oh, I can use the BME 688. I've actually got that one running before. All right, let's see if we can get the BME 688 working. I think I've done a reformat since then, so I don't think I've got the software on here anymore. Okay, let's pull up the Pimoroni BME 688. That's right, this is the quick one-line installer. So in theory, I should just have to type in some code. Let's get rid of this one. Let's use this one. If I type this in, ooh, did I actually enable I to C? that would be something that I definitely need to do. So I need, because I did do a refresh install on this one. Right, where's my Raspberry Pi configuration? There it is. Interfaces, no, I haven't got I to C enabled. Oh, what a pillock. Okay, I'll enable SPI as well while I'm here. That should be all I need. Click on OK. Right, yep. Now I've enabled it. I'm going to go in there again, double check it's still enabled. Oh, I hope that's all it was. It's really nice if I'm just an idiot, because being an idiot can be easily fixed. Yes, I have. Yep, full install, thank you. Right. Pimoroni, ls, and BME 688, no 680 here, ls, cd examples. And we'll just do a read all. Yep, that's working fine. That's brilliant. That's the sort of thing I was hoping for. Right, now that I've actually enabled I to C, let's see if I can get the other one working. Right, that's time of flight. Color sensor. There's the one. Right, let's get this connected now. Python detect particles.py. It's working. There we go. So that was it. It was complete user error. Now I will say that I probably wouldn't have worked that out. There we go. Trace back. So we do have an error there. We got right. Any movement of objects close to the sensor is likely to trigger detection of change. Okay, so I moved it. That's why that failed. Let's try again. Okay, so trace back. We are getting an error, but we're getting further than we were before. File not found error. Okay, well, we'll just try one of the other examples. Try get temperature. So Python get temperature.py. Apparently I can't spell. Get okay, so that's now running. Okay, we got a temperature. I always forget to turn off. One of the reasons I bought this particular multimeter was because it had an auto turn off feature, because I'm famous for forgetting to turn it off again. So there we go. We can see that it's got a color change on there, so it's indicating the temperature's on. So that's good. If there's just a problem with one of the examples, I can live with that. Right, so now we need read heartbeat. Python read heartbeat.py. Now, I'll imagine I need to actually hold this up against my wrist. Okay, it says it's starting in 10 seconds, but it's not doing anything. Probably. I'll probably need to run it as sudo. That one's not running at all. Okay. Now, it stopped as soon as I removed it, so maybe it's just not reporting it. I'm going to try running it through Thonny. Maybe it needs a console to report things. All right. Ooh, there's a test.py. I should probably try that. Run. Not found. Oh dear, oh dear. Right, we'll try the get temperature again just to make sure it runs in Thonny. So run. Start readings in 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we got temperature there. I think 30 degrees is a bit hot for this room, so I'm not sure it's actually particularly accurate. Maybe it's a case of it needs to be up close to something. I've got it up on my wrist and it isn't climbing in temperature. That's good. I definitely have SM bus installed. I installed that earlier. So it reckons I'm 31 degrees. No, it is climbing. 32, okay. So it is detecting a temperature change. Now I've taken it off, it's dropping down. So it does have some responsiveness there. That's not too bad. Stop. Right, now let's try one of the other examples. Let's try detect particles again. Run. Yep, so it's got that same error. Open file with timestamp W. No such file or directory. Note. Code should not be used on the basis of real time. Yeah, whatever. So it's not actually getting... Okay, so it's giving me the messages here. Delay 10. Get samples. Print. So it should be printing values. So where's it getting this not file thing? F right. Let's just get rid of this F right stuff then. See if that makes a difference. Because I just want it printed. Okay, we'll restore that then. There's a right there. I'm inclined to reduce all this nonsense down. I just want a live printed thing. I don't care about writing files. Yeah, I suppose I could just run it as sudo. I don't like running things as sudo until I've read the code. ls sudo python detect particles .py. Same error. So I'm literally running as an administrator. There's no reason it wouldn't be able to write a file. This is broken code I need to fix. Okay. I can live with that. Just means they haven't updated their library and something's probably changed on Raspbian, because I did do an update. Let's try graph heartbeat. Let's see if graph heartbeat works. Starting in 10 seconds. See if it actually does anything. Okay, interesting. So we got some text graph there. What happens if I... Oh, as soon as I moved it, I got an IO error. That's fine. Stop. I'll hold it against my wrist this time. Thank you for the follow. I appreciate it. Okay, so it's given me some kind of graph. Bit weird. It is working though. I can live with that. And it does drop down when I'm... Okay. Not the best design software I've ever seen, but it does demonstrate that the board is accessible and working. So that will do for now. I will come back and write my own code, I think, something with a proper graph and some numbers. This is really super basic, but at least he's not giving me readout errors and it seems to be accessing stuff. Yeah, matplotlib, something like that. Either way, my goal today is to make sure these boards work. So these two now go in the hardware works pile. Next, we'll try the color sensor. I think all of these connect in basically the same way. BH1745 Pimoroni. Yeah. Let's see if the instructions for this are any good. I like the one-line install they had on others, but they don't seem to have it consistently. Okay. Compatible with the Raspberry Pi Python library. Okay, that's where the instructions are. Just run this. Okay, we'll just run that. Yes, so that's exactly what this exercise is about, is making sure all the boards actually work. That way I can start integrating them all together and building my Star Trek tricorder with sensors, which is basically my ultimate goal with this project. What was I doing? I'll just copy and paste. At this point, all right, let's go back to that, and paste Python POP install. That's fine. Don't see any problems with that one. Then it's another clone their GitHub job. And interesting, they want me to install the unstable version. Control V doesn't always work. All right, copying examples, ls, examples. Right. Let's try detect.py. So Python detect.py. Right, so it's found it. Good. So now we're going to try hex color scan. So in theory, this sensor should pick up the color of whatever's held close to it. I am installing some sensors and testing them on my Raspberry Pi. This is a color and luminance sensor. So in theory, it should report the RGB hex value of anything I hold the sensor up against. So we're going to find out what color my skin is. I'll finally find out if I'm a black person or not. And my wife, who is Ghanaian, would love to know this information as well. Python hex color. You can tell they're British because they spelt it with a U. Thank you for the gifts, I appreciate it. Oh, it's actually detecting colors in hex. So those are the hex values of my skin, apparently. Let's try something a bit more solid color, like this yellow. Why so blue? Let's see if I can get something close to white. That'll be a nice easy one to read. I've got a white piece of plastic here off my printer. Yeah, I mean, that's pretty bright, and it's not a pure white, so that's fair enough. Do I have anything whiter, like paper, for example? And that's pretty light coloured. Let's try something dark, like this grey battery case. Values are dropping. Something darker, blacker. Let's try my PSP. Though it may be detecting the amount of reflection off this device. Do I have anything matte black? That's kind of matte black. Definitely dropping in value. I'd have to type these into an actual... What I need to do is make a Python thing that actually shows the colour being represented, which wouldn't be too hard, actually. I just got to draw a square every time it updates. But it is at least doing something, so I will take that as a win. So it's got two sensors. Let's try raw colour. PY. Okay, so now we're getting raw RGB, so I'm just checking my desk. C is the luminance level, so maybe it needs to be further back. I'm probably holding it too close, because the luminance level dropped massively when I pulled it away then. That will probably give us more accurate values. Yeah, okay. Might need a color calibration. I So at the moment, I'm really just testing that it works. There is a config there, so there may be some calibration I need to do. But either way, the sensor is working. That's my priority right now. So that's 3 sensors. I've demonstrated send data. The next one is 6 degrees of freedom with magnetic compass. Hey, how's it going? So that is the LSM 33D. Pimoroni LS, what was it again? LSM 33D. So this is a magnetic compass and accelerometer all in one board. And Python library. Okay, just need to run this. Yeah, Control V doesn't work when I'm pasting into console. Thank you for the follow, I appreciate it. So the ultimate mission of this is to take all these sensors at one point, install them into a Raspberry Pi and make a Star Trek style tricorder. It's Control Shift V, is it? Let's try that one. Yep, that works. Thanks for that tip. I'll remember it. Hey, how's it going? Now install that. Would you like to copy examples? Yes, I would. Thank you. ls examples ls and let's run accelerometer. Python XLE rom etor.py. So I'll bring that down for everyone to see. Okay, it's not really changed. Let's try running it again. Okay, so it's just locking in at 2G. Oh, I see. So I'll detect subtle motion. Not sure it's maxed at negative 2G though. I'll have to work that one out later. Let's try the magnetometer. I have seen the Flipper Zero, but I don't really remember what it is. I don't think it particularly impressed me at the time. Magnetometer.py. Learn to spell, man. netometer.py. Okay, so that one's giving a bigger reading. And then it freezes. Okay, so it gives a burst of reading and then it just stops. So maybe I'm putting connections out. That might be what it is. Let's try running that again on the accelerometer. Yeah, it's because I pulled out a cable. That's why I wasn't getting. There we go. We've got orientation sensor there. And magnetometer. Yep, that's working well. It's Tamagotchi like a multi-tool, branch of sensors and a GPIO. Okay. I'm probably thinking of something else then. Yep, I find those readings believable. That's that sensor board working. The next one is 3 degrees of freedom. So this is another accelerometer, but it doesn't have the magnetometer in it. I wonder if I could be cheeky and just run the same. No. I do have to download the right library. Right, so this is the MSA 301. Right, there we go. Python library. Yeah, another bunch of scripts to run. Thanks for the likes, I appreciate it. You're on DevBrunt, so you can make your own. Cool. That's that installed. Clone this. Go into this folder. Thank you for the Control Shift and V. That has sped things up. And there we go. Unrecognized options because I cut the E off, that's fine. Install Python library. Would you like to copy the examples? Yes, I would. ls and examples. ls. Oh, interesting. So it's got detect, axis move, free fall, double tap, and accelerometer. So it's got some more interesting examples in this one than the last one. Yep, that's changing values. Yep, that looks good. ls. Let's see if double tap works. I'm quite interested in that one. That's a good use for the sensor. Double tap firmly or near the sensor. Double tap detected. So if I hold that against a desk... Nice. I've literally just turned my desk into a mouse button I can double tap. That's actually quite cool. I could have some fun with that concept. Detect axis move. Move sensor to trigger. So this one won't respond until you actually move it. That's cool. Yeah. I think it'll be quite hard to organise people to buy components and then work with me live there. Though maybe if I do a regular thing, like every Saturday or something, people can join in. I'm not going to try the free-fall one because obviously I'd need to drop the sensor and it's connected to a very short wire. So I won't worry about that one. But that is another board that is working. What else do we have? I think we're down to one now. One left. Time of flight array. Now this one will be interesting. This one will detect distances. There we go. So that's the time of flight sensor. So what's that? This is the VL53L5CX. This will be good in robot vision. Because it's got an array, it means it can detect things coming into its vision and what direction they're coming from. So this will probably end up being a robotics project eventually. Python library. Must enable I2C. That's fine. Oh, okay. So requires firmware load on startup, and it's slow. Add a bit rate to the I2C line config. Okay, so I've actually got to change my boot file. Alright, where's my boot? There it is. So I need to go into my local config.txt and I need to set up this bit rate. So add the line, so I'll just go to all and I'll add it there, save it. Permission denied, that's fine. That's probably because I didn't run it as admin. I know what I'll do. Apt-get install gedit. Yeah, I'm installing gedit now. Sudo gedit config.txt. There we go. Paste that in there, save it, and we're done. Now I've got to reboot my machine. So now we know that this one has a far higher data rate than the other ones. As you can see, my Pi 400 boots up relatively fast for such a low-powered desktop machine. And that's because of the SSD I've installed into it. I think an M.2 drive is overkill for a Raspberry Pi. It really doesn't have enough bandwidth on the PCI Express lanes. So I'm just going with a USB Type-C, which is still probably too fast for it, to be honest. You get to a point of diminishing returns with a Pi very quickly. Ooh, fatal exception. Input has no files. Compilation terminated. I did type in the right code, didn't I? Python setup install user. Yep, that should just work. Oh, naughty, naughty Pimoroni, you're not updating your stuff. Okay. Let's have a look at this setup file. Yep. It is a pain in the ass. Yeah, it's not going to run without the setup process. There's a bunch of software libraries apparently it's needed. And it needs a screen as well, which I do actually have. So that's not a big issue. But This one's going to take a little bit more. That's a shame, because this is one of the ones I was most excited about. I'm going to try the C libraries as well, actually. Oh, they're not providing C libraries. But they have MicroPython for the PyPico. Interesting. Someone wants me to use NeoVim. No one else is reporting issues right now. Let's have a look at the GitHub. Yeah, there's an issues listed. Need to run sudo make install. Ah, interesting. Instructions didn't work for me on Bullseye 32. I need to run sudo make install before things run. Let's try that. No rule to make target install. Okay. It's probably because I'm in the library and I need to be in the base. Let's try that again. Right. Sudo make install. Let's see if that's running now. That looks a bit better. This isn't listed in the README. Well, someone's actually fixed it for them. They just haven't bothered to actually... that's not very good, is it? CD examples. Okay. So... yeah, so everything requires a 240 by 240 LCD display, which luckily I do have. But if I didn't, that would be a pain in the butt. I just want to see the raw data, to be honest. We got a test.py, Python test.py. Errors, okay. Apparently this needs Symbus 2. Let's try it now. Uploading firmware, please wait. There we go. Okay. Wow, their documentation really sucks for this one. If I hadn't looked at the issues, I wouldn't necessarily have known anything. I think I've probably... But on the plus side, it's going to make the video I make of this more useful. So it is giving an array, and it is returning the data. I've no idea what any of this data means yet. Oh yes, detecting the shape of my fingers, I bring it into range. Interesting. So when something's in front of it, it's returning a false. And when something's far away, it's returning a true. I'll try putting something. So it's inverted. It's coming from the other side. Ah, it's because I've got it upside down, of course, because I'm an idiot. There we go. Yeah, you could probably produce an image from that data. So there we go. We've got all my my sensors are now working. I've got all the software installed. So that works nicely. And for that time of flight one, I've got some updated instructions to write and publish as well. So now what I've got to do is work out how I'm going to combine all of these into a single board and address them from my Raspberry Pi. And I think that comes to the natural conclusion of this live. So thank you everyone for joining me today. I hope you haven't been too bored. Thank you for supporting me in these projects. And I hope to see you all again very soon. Thanks again.